Assalamualaikum warahmatullahi wabarakatuh. I'm Arif Iskandar bin Sirajuddin, student ID 18002402, and we'll be having Fluid Mechanics Lab 2. So today's topic is Bernoulli's theorem. So it was first derived by Swiss mathematician Daniel de Bernoulli, hence the name, in the fact that the total mechanical energy of the flowing fluid comprises of energy associated with fluid pressure, gravitational potential energy of elevation, and the kinetic energy of fluid motion remains constant, hence there will be no energy loss. So three of the main assumption of the fluid is that it is incompressible, it has steady flows, and it has no friction loss. This is the Bernoulli equation: pressure plus 1 over 2 rho volume square plus rho gh equals the same. So this is the main diagram of what the effects of it in the application of in real life, which is the pressure of fluid decreases when the velocity of fluid increases. So real examples that we can always see this in the airplane wings and cars such as Air1. So this type of shape is called aerofoil. So objective of this project is to determine whether Bernoulli's theorem could be applied to a venturimeter consists of a converging part and diverging part. You can see on the diagram that is a venturi tube. So it has a converging part with lowering diameter and a diverging part. So the method used is that this Bernoulli's theorem will be accepted through the use of a venturi system connected with a manometer in order to measure the head, total head, and velocity of fluid at target points along the flow. So from the theorem, when fluid flows through a pipe, the total head at any other cross section will remain constant. From the equation, pressure over rho gravity plus volume square over 2 gravity plus z equals to constant. This is the experimental setup from this Bernoulli theorem experiment. You can see we have the air bleed valve, the manometer tube, and the unions at the bottom, gland nuts, water inlet, adjustable feed to make it horizontal and stable, inside section, and the hypodermic probe. So what is the procedure actually? The manometer tubes are checked properly connected to the corresponding pressure to make sure they are air bubbles free. Discharge valve are adjusted to high measurable flow rate. After level water is stabilized, the water flow rate is measured using a volumetric method. The hypodermic tube connected to a manometer is gently slide so that the cross-section of venturi tube at A will reach its end. Step 4 will be repeated along the other section. We have B, C, D, E, and F section. And step 2 to 5 is repeated with 3 other decreasing flow rates by regulating the venturi discharge. The velocity is calculated using a Bernoulli's equation, and hence the velocity is calculated using continuity of the equation, which is V equals to QAV over AI. The difference between two calculated velocities is determined at the end. So this is the calculation methods you use. The first one is used to find the VIB using Bernoulli's equation. The second one is the area, find the area of each cross section with given diameter A, B, C, D, E, F. So in the chart, it's assumed that it is given for DA is 26.0, DB is 221.6, DC is 16.0, DD is 20.0, DE 22.0, and DF is 26.0. So the third calculation is volumetric flow rate of trial 1, 2, and 3. You can see Q average equals to volume of water over time taken. And lastly, finding the VIC using the continuity equation earlier. So this is the result of in discussion of the first trial. You can see that we varies between all cross section of tubes A, B, C, D, and F. You can get the volume of water and the time taken and flow rate from the trial. So continue the second trial. Same as the first trial, we'll use the same method, which is repeated until the third trial. And the last one is the trial. You can see that we have a difference here. We have a negative value at D cross section. That will be regarded as a parallax error because we won't be having a negative value actually. So in conclusion, high velocity of fluid flow result in low pressure, and based on quantity equation, smaller area result in higher velocity. The result proof of both equations could be used to determine the velocity of fluid flow in a manometer. The pattern of increasing and decreasing at the converging and diverging portion is the same. As the velocity increases, the total head pressure also increases for both convergent and divergent flow. Thank you for your time. Assalamualaikum.